we probably shouldn't start the video off with the big finale.
Good point. Elephant toothpaste videos have become insanely popular over the last few years. Popular channels like Mr. Beast and Mark Rober, which have 1 or 2 more subscribers than we do, have really popularized the subject in the last few years.
But these experiments have been around for a long time.
The earliest one demonstrated on YouTube that I can find was done by a channel called Kim Toddler, and that was 13 years ago. And it doesn't appear they make videos anymore, which is a shame because they were clearly ahead of their time. In today's video, we're going to show you 4 different ways to make an elephant toothpaste reaction, 2 of which are completely safe to do in your own home.
And the elephant toothpaste that is produced is absolutely safe to touch.
And on a side note, as a parent, I learned that a quick lesson on proper utilization of safety equipment prior to the lab is probably a good idea. And then the next 2 experiments we'll do inside the jack-o'-lanterns with the formulas that have become really popular over the last few years.
Why pumpkins, you ask?
Because every year we go to a pumpkin patch and cut pumpkins, and it is always a super fun time, and we always end up with way more pumpkins than we actually need. And the annual getting completely lost in a corn maze is a side bonus that's also a lot of fun as well. For the first experiment that's safe to do in your home with your kids, you're going to need hydrogen peroxide, dish soap, yeast, and some food coloring. Food coloring, of course, is optional, but it does make more fun. This is an incredibly easy experiment to do things in the house. But first things first, we have to spend the next 10 seconds carving some pumpkins. For the top of the pumpkin, I ended up cutting something like a dovetail pattern that is used in woodworking joinery just in case the reaction was strong enough to blow the lid of the pumpkin off. And it turns out it's a pretty good thing that I did that. The first experiment that we're going to do is completely safe to do in your home. And since we're only carving 2 pumpkins, we're going to set those aside and we're going to do the initial experiment in plastic bottles, and you can do the same thing as well. Also, if you're not interested in doing elephant toothpaste in your jack-o'-lanterns, stay tuned to the end of the video because I'm going to talk about another opportunity on how you could use your pumpkins in a manner that's very rewarding.
And later in the video, we will explain the science on what is happening here, because that's what we do here on our channel.
For the first part of the experiment, you're going to take your 3% hydrogen peroxide and pour some into your water bottle. And then you're going to follow that by about a half a tablespoon of dish soap. We used Dawn and it seemed to work out just fine. The next step is optional, of course, but that is putting a few drops of food coloring in there to spice it up a little bit. If you have an extra set of hands, while one solution is being made, you can have somebody else make the other solution, which is basically just dissolving yeast in some warm water. Swirl your first solution gently around, mixing the hydrogen peroxide, the dish soap, and the food color together. Once your yeast is nice and dissolved in the warm water, mix the 2 together, and there you have it, your very first elephant toothpaste demonstration. For the second reaction, we only made a minor change to the recipe, and that was adding a little bit of sugar to the yeast in the warm water when we dissolved it. We did that because the back of the packet said to do it to activate the yeast, so I was curious to see if it would make a difference. Everything else, however, with the experiment was kept exactly the same. And as you can see, other than the color being different because of the food coloring, the experiment didn't really change significantly. So with those 2 experiments under our belt, it was time to go outside, do the experiments inside our jack-o'-lanterns, and see if we can scale up the demonstration a little bit. Here is our setup, and to do this, I'm going to put the hydrogen peroxide solution inside the pumpkins. And I don't really want to pour in the second solution, slam the pumpkin lid down, and then run away. So I'm drilling a hole in the back of the pumpkin, and we'll use a syringe to rapidly mix the 2 solutions together. For the first 2 reactions, we are going to tweak the chemistry a little bit. And this is the reason we most definitely need to wear safety goggles and protective equipment. But out here, to see if we can get a bigger reaction, we're going to use 30% hydrogen peroxide. In one pumpkin, I will be using the same yeast as the catalyst, and in the other pumpkin, I will be using a different catalyst made up of potassium iodide. And since we're using words like catalyst, now let's take a moment and explain the science behind what exactly is happening. Keep in mind that water is often referred to as H2O because it has 2 hydrogen atoms and 1 oxygen atom bound together to form a molecule. Well, hydrogen peroxide is kind of similar in that it has 2 hydrogen atoms, but it has 2 oxygen atoms instead of 1. And those atoms come together to form a molecule that looks something like this. But this molecule is not as stable, and an oxygen atom is always trying to leave. When that oxygen leaves, it now leaves a molecule with 2 hydrogens and 1 oxygen, essentially water. So hydrogen peroxide is continually breaking down into water and oxygen. But it's not a very quick process, and that is why we use a catalyst. A catalyst, like the yeast we're using in today's experiment, is any substance that increases the rate of a chemical reaction without itself undergoing any permanent chemical change. So as I mentioned, the reaction is hydrogen peroxide breaking down into a water molecule and a free oxygen atom. That reaction goes pretty slowly, but when we add a catalyst, it goes much faster. All of those free oxygen atoms bind with other oxygen atoms, creating oxygen gas, and that is the reason we use the dish soap for this experiment. To truly create that elephant's toothpaste reaction, the Dawn dish soap serves to capture that oxygen gas and encapsulates it into many tiny bubbles, which creates that foam which everybody has now called elephant's toothpaste. Let's see how it all comes together inside our jack-o'-lantern. The first demonstration we're going to do with 30% hydrogen peroxide is to switch the catalyst from the yeast that we had been using to potassium iodide. The pumpkin on the left is going to be our potassium iodide reaction, which I already have dissolved in the container behind it. Here you can see I'm using a 50 milliliter syringe and I'm going to inject the pumpkin as fast as I can, and let's watch what happens. Remember, I've already put the 30% hydrogen peroxide inside the pumpkin with the straw going straight into the container. This is a cool shot because you can see all the heat being produced by the reaction. So as you can see, the potassium iodide and the 30% hydrogen peroxide create a much more forceful reaction. So now for our final reaction, it was time to see what the regular yeast that we were using in our original reaction would do with the 30% hydrogen peroxide versus the 3% hydrogen peroxide. And the answer is, not too much. It looked like, however, we did manage to create some nice pumpkin stew. Or at least a jack-o'-lantern that looks like it got into Grandpa's cough medicine. So there you have it, several different ways to do an elephant toothpaste reaction. If you want to keep it simple and super safe and not too messy and inside your home, just stick to regular old hydrogen peroxide and yeast and your kids are going to have a great time. As always, I will have a worksheet that goes along with this video posted to our website pretty soon, so you can be sure and check that out. To get back to the point I mentioned earlier in the video about what to do with your pumpkins at the end of the season, I just want to let you know that there is an alternative to just throwing them away. If you are new to our channel, then you may not realize that we are pretty big into animal rehabbing. And while it might not be something you have time for in your family, if you Google local animal rescue and sanctuary in your neighborhood, you will probably find something, and I can almost guarantee that they will gladly take your leftover pumpkins and jack-o'-lanterns and they will use them for food for a lot of the animals they're trying to rehabilitate and release. It's one small thing you can do to help them keep their costs down, because generally food is a big part of their already cash-strapped operating budget. And to end the video on a completely different note, go back and check our videos from last year where we did 2 fall-specific videos. One where we talk about the color changing of leaves and a very neat demonstration you can do at your home to prove that point, and another real quick one where I show you how to create a magic wand that literally looks like it's floating in the air based on the science of the center of gravity, which will make you the center of attention of any Halloween party that you're going to. Although everybody on the planet is going as a character from the Squid Games this year, so it probably doesn't matter. But that's it for this week's video. I hope you enjoyed it. Hope you learned a little bit about chemical reactions and elephant's toothpaste. Have a great day, everybody, and we'll see you next week.